Alrighty, we are given a survey found that 66% of callers complain about the service they receive from a call center. So the complainers are 0.66. So then the non-complainers would be 1 minus that, right? 1 minus, because all probabilities have to add to 1. All right, it says, what assumptions, if any, are necessary to calculate the probability? Definitely these are independent. Okay, they're completely separate. Just because one complains doesn't mean the next is going to complain, things like that. It says, find the probability that the next 3 callers complain. So what that means, the next 3 callers complain, that means complain, 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 which is 0.66. And if you heard me say complain and that one complained and that one complained, that's multiplication. Remember, and in probability means to multiply, and because these are independent, we just simply multiply them. So the probability the next 3 would complain, and it says round to 3 decimal places, is about 0.287. Again, every one of these assumptions are going to be that different calls resulting in a complaint, definitely independent. Then it says the probability that 2 callers complain and the third does not. So that means complain, complain, and does not complain. And 34. Once again, complain and not complain. I'm multiplying these 3 and I get the 0.148. These are still independent. The probability that 2 of the next 3 calls produce a complaint. Well, 2 of the next 3 calls producing a complaint, so 2 complained, is this. And then, but it also could be the first one complained, the second one didn't, and then that one did. And then it could also be the first one did not complain, but then the last 2 complained. If you notice, these probabilities are going to be the same. I guess I shouldn't copy that. The complain 0.66, the not complain 0.34, the complain 0.34, 0.66, 0.66. I'm going to multiply these. Even though they're in different order, you're still going to get the same value, right? The 0.48, the 0.48. And guess what? I'll get it here again. And so when you read this, you're saying that the probability that 2 out of the 3 next callers produce a complaint. That means either the first 2 complained, or the first one and the last one complained, or the last 2 complained. And you're going, why is she going or? Because or in probability means to add. The first 2 complained, or the first and last one complained, or the last 2 complained. So I add those probabilities, and that's where you see the 0.444. Again, these events of these calls are still independent. Then it says the probability that none of the next 10 calls produce a complaint. Well, you could sit here and do the 0.34 10 times, or that's the same thing as 0.34 to the 10th power. I get that little exponent by the shift 6. So that's didn't complain, 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 didn't complain. Did you count? I said it 10 times. So none of the next produce a complaint would be 0.34 times 0.34 10 times. When I hit enter, if you get something like this in Excel, that's just scientific notation, which just means that I'm going to move the decimal 5 places to the left. If you don't like that, then all you have to do is simply, well, I thought it would let me do this. I guess it won't. No. So I guess Excel does that when it's such a small number. I think there's a way you can format. There's got to be a way you can format this. Yeah, so see, it's in scientific notation. I want it to be formatted as a number with the decimals. Remember again, scientific notation. Let me go back to that. That E minus 0.5 says this is scientific notation, and you're going to move that decimal 5 places to the left since that's a minus sign. But again, I'm too lazy to remember how to do that, so I just simply switched it to a number, and it says it wants 7 decimal places. So in this case, if I get rid of some of these, you will see that's 1, 2, 3, well, I lost my count. 1, 2, 3, 4, 5, 6, 7 decimal places, and that's how you get the last answer.